Any question?
No, I
No,
understand.
no. Okay, then we go on to the question here. True or false? What is the question? True or false? Dimensionally correct. Oh yeah, the question is, they say if you replace the v here with
Mm-hmm.
r over t, r over t. Now, if you replace the v with r over t, it is dimensionally correct. The dimension will still be the same, but
Mm-hmm.
it is not useful because it's moving in a circle and it has velocity, and we are not making use of the velocity. So
Okay.
although the formula you replace with r is correct, but it is not useful. You replace the v here with r over t, so it's not
Okay.
useful. Now lastly, we have this exercise 1.2, which is the Einstein equation, the
Okay.
equation for energy E equals to mc squared. Now I read the question, right? Or maybe you can read the
Mm-hmm.
question.
In physics, energy E carries dimensions of mass, time, length squared divided by time squared. Use dimensional analysis to derive a relationship for energy in terms of mass, m, and speed, v, up to a constant of proportionality.
Okay, so they want us to find the relationship between the
Speed.
energy, mass, and velocity. Again, it is like our question here. We know they are related, but exactly how they are related, we don't know.
Okay.
This with this here, the energy with the mass and the speed here. Okay, now first of all, I try to find out what is the dimension for energy, or energy. I think it's here. Okay, energy. Oh, there's no energy here. Work. Energy is the same as work. So this energy is the same as work. It is the force multiplied with the displacement.
Displacement.
Force multiplied with displacement. So coming back to our question here, right? So the energy is the force multiplied with the displacement.
Displacement.
Okay, then the force is Newton's law, mass times acceleration, then times the length.
Mm-hmm.
Now the first term here, mass, has a dimension of m,
M.
dimension of m. Then the second one, the acceleration,
It's
has a dimension of L over t square.
over t square.
Okay. Then the displacement has a dimension of L.
Of L.
Okay. Now I group the like terms together. Those that they are the same letter, I group them together. So I look for M. There's only one M here. So I just
Mm-hmm.
put M lah. Then I look for L. Oh, there are two L's there. One L here and one L here. So finally we have L square.
Okay.
L square. Then we have this T square, but it is at the bottom. So if I want to lift it up to the top, what must I do? The T square at the bottom.
Change it to -2.
Correct. So I change to negative 2, T to the power negative 2. So this is the dimension for energy. This whole thing, dimension for energy. This is
Okay.
the dimension for energy. And I know this energy is related to these two factors, M and V. They told us already, because we are not supposed to know how what are the factors that's related. We only want to find out the relationship, the exact relationship. They have to supply us. They have to tell us, oh, this
Okay.
factor and this factor, they are related. So they told us energy. We find the dimension for energy. They told us, oh, this is the mass. So we find out the dimension for mass. But to the power of what? Don't know.
We don't know.
So I call it P lah. So I call it P.
Okay.
Then we know it is given to us that it is related to the velocity, but exactly in what way, to the power of what, also
Don't
don't
know.
know. So I call it Q.
Q.
Q. So now m to the power of p, right? The mass is, the dimension is m to the power of p. Velocity, the dimension is L over t. The dimension is L over t. So this v, I replace it with L over t. And this thing raised to the power of q. Raised to the power of q.
Mm-hmm.
So when I expand them, mp, I just copy m to the power of p. The q here, L to the power of q. L to the power of q. Then I also have t at the bottom to the power of q. T at the bottom to the power of q, I can write as what?
Negative Q.
Negative q. When at the bottom you raise the top, become negative. Okay, finally, I have the dimension for energy. I also have the dimension for mass and the velocity. So now I compare the two of them, like what I have done earlier here.
Mm-hmm.
How to put it? Yes. Like what I've done earlier here, you see the previous question. I
Mm-hmm.
try
Yep.
to match them. I try to match them. So I try to match this thing here, the energy with the m and the velocity. So when I match them, they are matched in this way. Right? I copy this, put down here. I copy this and I put down here. So now is the time for us to compare one by one. Compare the m with the m, compare the L with the L, compare the T with the T. So
Yep.
in this way, when I compare the M with the M is to the power of P. The M here, no power. No number there means it is to the power of 1. No number means to the power 1. Right? So the
Yep.
P is equals to 1. P, the P here is equals to 1. The P here, why not? The P here is equals to 1, the m
One.
here. Then I compare the q, L to the power q, with the L square here,
And to the. Mm-hmm.
with the L square here. So
So
q is
Q
actually
equals two.
equals to 2. So now I take the p and q, I put back
Put it
into
back
the
in.
equation here.
Question.
Put back into the equation here. So E equals to m to the power of 1, v to the power of 2.
Of two.
So this is the formula, right? This is the
Mm-hmm.
formula, but we don't know what is the proportionality
Personal
constant,
constant.
the k in front of it. So we cannot find out the value of k unless they give us a pair of values like the price of the book and the number of books. You remember the
Okay.
price of the book and the number of books, you are given a pair of values like that,
Mm-hmm.
then you can find the proportionality
Proportional
constant.
constant.
So now we don't know, right? So we only know
Mm-hmm.
energy equals to mass times the velocity square.
Velocity square.
That's all. And to be exact, this is energy equals to mass times velocity. If the velocity is the velocity of light, then this will be the Einstein energy equation. E
Okay.
equals to mc squared. Any question?
No. No, sir.
No. Clear or not?